Imagine you're building a smart contract that manages a voting system, or maybe an online store. You need a way to store numbers like votes, words like names, true or false answers, and even Ethereum wallet addresses. That's where data types in Solidity come in. In this video, we'll cover everything you need to know about data types in Solidity, from the basics like numbers and strings, to advanced ones like arrays, structs, and mappings. By the end, you'll understand exactly how to use them in your smart contracts. So what are data types? In simple terms, a data type tells Solidity what kind of value can be stored in a variable. Just like in real life, we have containers, a bottle for water, a box for clothes. In Solidity, we have data types for different values. Example of variables with different data types. Unsigned integer public age 25. String public name Alice. Bool public is registered equal to true. In Solidity, data types are mainly divided into two categories. 1. Value types. They hold the actual value directly. 2. Reference types. They hold a reference or pointer to where the data is stored. Value types. 1. Unsigned integers, Uint. Uint stands for unsigned integer. It means whole numbers, no decimals and no negatives. Code example. Uint public age equal to 30. Only positive number. Note, by default Uint means Uint 256, which can hold very large numbers. 2. Integers, int. Unlike Uint, the int type can also store negative numbers. In public temperature is equal to -5. Think of Uint as counting apples. You can't have negative apples, but int is like temperature where values can go below 0. In Solidity, Uint and int are fundamental data types used to store integer values within smart contracts. The only real difference is that Uint can't handle negative numbers, while int can. Solidity can have signed a regular int or unsigned Uint integers. A regular int type means that the integer can either be positive or negative with a negative sign. Uint unsigned integer has a different range than the signed one. For example, Uint 8 ranges from 0 to 255, while an int 8 can hold from -128 to +127. So the items in the range are the same, but the start and end integer in it are different. Another note, why is it from -128 to +127? Because 0 is also an unsigned integer. So positive integers begin from 0 to 127, making 128 total. And negative integers go from -1 to -128, again, 128 total. This makes the gross total 256. Uint 256 is same as Uint in Solidity. In Solidity, the terms Uint 256 and Uint can be used interchangeably. Both represent a 256-bit unsigned integer. This means they have the same size, same range, and same behavior. However, this is only true in Solidity, not in all programming languages. A recommended approach is to always use Uint 256, even when you can just write Uint because 1. It clearly reminds you and others reading your code that the variable is a 256-bit unsigned integer, helping you keep your code consistent and predictable. 2. It prevents you from developing the wrong habit of using Uint in other languages, where it may have a different size or meaning, which could lead to errors or incorrect data handling. The same logic and range concept applies to other integer types too, such as int 8, int 16, int 32, int 128, int 256, and their unsigned versions Uint 8, Uint 16, Uint 32, Uint 128, Uint 256. 3. Boolean, bool. Boolean variables can only be true or false. Bool public is active is equal to true. This is useful when you want to check conditions, like if a contract is active or not. 4. Address. Ethereum accounts and contracts each have an address. The address type stores that unique identifier. Address public owner is equal to this address. You'll use this often to send or receive ether. 5. Bytes. Bytes are used to store raw data. The most common is bytes 32, which stores 32 bytes of information. Bytes 32 public data is hello blockchain. 6. Enum. Enums let you create your own set of options. They make contracts easier to read. Code example. Enum status pending, shipped, delivered. Status public order status is equal to status.pending. Part B reference types. 1. Arrays. Arrays let you store a collection of values of the same type. Uint array public numbers is equal to 1, 2, 3, 4, 5. Arrays can be fixed size or dynamic. You'll use them when you need a list. 2. Structs. Structs allow you to group different variables under one name. Struct student, string name, Uint age. Student public student is equal to student, null is X and 20. Think of a struct as a form where you fill in multiple fields about the same person or object. 3. Mappings. Mappings are like dictionaries. They connect a key to a value. Mapping address adds Uint public balances. This is often used for tracking token balances, where each address has a number of tokens. Value versus reference types. The main difference is value types store the actual data directly in the variable. Reference types store the location where the data lives. So to recap, value types include uint, int, bool, address, bytes, and enum. Reference types include arrays, structs, and mappings. These make up the building blocks of all smart contracts. Now it's your turn. Try these examples in Remix IDE. I've shared the code in the pinned comment. If you found this video helpful, don't forget to like the video, subscribe to the channel. Happy coding.